Hi, welcome to this episode of Nerd Bar Physics. In this episode, we're going to be talking about rectangular components of a vector. So don't get intimidated by how it sounds. It's not that intimidating. You find that most of the time when you're dealing with a vector or with several vectors, they don't normally point in the same direction, and you can't always use the head to tail method because that requires you to be precise and to use rulers to measure the vectors, and it takes a lot of time. So in this way, we get to resolve vectors into their x components and their y components so that we can deal with them that way. So take, for instance, you have a vector. Let's call this vector r, and we place this vector on the x or y plane. With reference to the x-axis, it's going to have a certain value of degrees from the x-axis that we'll call theta for now. So if you remember from the first video, we were able to resolve vectors into components. So you've got your x component and your y component, but we're just going to go through that a little quickly. And yes, so to find our y component, which we're going to call ry, we will have to use SOHCAHTOA. We'll do the same also for rx. So if we're dealing with we'll have that sine theta is equals to the opposite over the hypotenuse, just like we said in the first video. And in this case, our opposite is ry and our hypotenuse is r. So if we take this equation and say sine theta is equals to ry over r and make ry the subject of the formula, we'll have that ry is equals to r sine theta. So we're going to take that as an important equation that we're going to use later. Similarly, if we take cos theta from SOHCAHTOA, we know that cos theta is equals to the adjacent over the hypotenuse. We'll have that the adjacent is rx and our hypotenuse remains the same, which is r. And if we take this equation, cos theta is equals to rx over r, and make rx the subject of the formula, we're going to have that rx is equals to r cos theta. Similarly, we take tan theta and we say that tan theta from SOHCAHTOA, tan theta is equals to the opposite over the adjacent, and our opposite in this case is our ry and our adjacent is our rx. So we know that tan theta is equal to ry over rx. Excuse me. So if we take the same equation and substitute ry for the first equation that we had and say ry is equals to r sine theta, and we do the same for rx, we'll have that tan theta is equals to r sine theta over r cos theta. And we can see that the two r's cancel out and we remain with the equation tan theta is equals to sine theta over cos theta. So now that we have that under wraps, we can easily compile any vector into its x component and its y component. So take, for instance, you have a vector A. We can find the x and y components of this vector by using the same equations that we had previously. So note that these equations that we're using only apply if the theta that you're using starts from the positive x-axis. So in this case, we're going to have that our ax and our ay respectively will be, ax is going to be a cos theta and ay is going to be a sine theta. So yeah, like I mentioned before, an emphasis on the theta. We have to make sure that the theta that we're using starts from the positive x-axis. So if you have a vector like in this case, vector A, our theta will start from the positive x-axis to where vector A is. If your vector is vector B and is in the second quadrant, still you're going to use theta starting from the positive x-axis to B. These two equations are always going to work, whether or not the angle and the vector that you're using form a right angle triangle. These two equations are going to work. So yes, at this point you can use these two as standards, with an emphasis that your angle should start from the positive x-axis. So if you have a vector C that's in the third quadrant, again, start finding your angle from the positive x-axis to the vector C. That's the angle that you're going to use in these two particular equations. And if you're in the fourth quadrant, if you have D in the fourth quadrant, you do the same. You start from the positive x-axis all the way to vector D. And it's important that we also understand what our components would look like, what they would look like if we resolve them in two vectors. Where would our vectors be? Take, for instance, you have vector A. Your x component and your y component are going to look like this. So your x component is a shadow that is made along the x-axis from your vector. And you can say the same for the y component. In this case, we're making it look like a triangle. It can be on either side. The y and x component can be on either side of the vector, but it's easier for us to look at it in this way. So this is how your x component, where your x component will be, and that's where your y component would be. If it's in the second quadrant, if you have a vector B in your second quadrant, your x and y component will look like this. Your x component in this case is going to be negative because it's on the negative side of the x-axis. But your y component is going to be positive because it's still on the positive side of your y-axis. And if you have a third vector, vector C, in this case, both x and y components are negative because the x component is on the negative side of the x-axis and the y component is also on the negative side of the y-axis. If you're in the fourth quadrant, you'll find that your x component is going to be positive while your y component will be negative. So even as you find your answers, when you're resolving a vector into its two separate components, you're going to find that your x and y components may sometimes come out positive or negative. So that's going to give you a picture of where your vector will be and what it will look like. So it's important that you understand what vectors will look like based on their components. And we're going to end this video on this note. If you have any questions, please leave them in the comment section below. And if you like this video and if it was any help to you, please click the like button. And if you're not yet subscribed, please smash that subscribe button. And yeah, let's be a family. Thank you.